Hey everybody, my name's Abby and I am one of the A&P tutors over at the Math Science Learning Center, and I just wanted to make this quick video of an overview of the epithelial tissues because I know that this is something that can get a little confusing and kind of brushed over in class, so I just wanted to give you guys this resource that hopefully will prove a little helpful. So let's start with our simple squamous epithelium. So any type of epithelium that is simple, we know that it's only one layer. It's super simple. And so when we talk about simple squamous, we have to realize this is like the most fragile epithelium that there is. And so it is going to be found in places that are kind of naturally protected by the body. And that's a way to help remember it. So we'll find it in places like the air sacs of the lungs, the lining of the heart, and in our blood vessels, and it makes up our serosa as well. And its main purpose is secretion and absorption, which I'm sure you've heard in class, but I'll just say it again. Simple squamous is going to be really influential in secretion and absorption. And that makes sense, right? Because it is only that one layer, so it's easy for things to go in and out. And another thing that it does is it's going to help reduce friction by secreting lubricating substances in the serosa. And that's really important because we don't want our organs rubbing up against each other because that could be pretty detrimental. Next up is stratified squamous epithelium. And so stratified squamous, I think, is pretty easy to identify because it has that kind of crushed squamous look that squamous cells have, but also you're never going to see such a thick membrane anywhere else in any of the other epitheliums. It just really, if you look at it, it's pretty gnarly because it's composed of those several cell layers. And a good thing to remember is that stratified cuboidal and stratified columnar, they're never going to go beyond 2, 3, maybe 4 layers. So if you ever see more than 3 or 4, you should be assuming that it's stratified squamous. And the big function here is that it's going to protect underlying tissues in areas subjected to abrasion. And so an example of that would be that it's going to be found, the non-keratinized version will be found in the lining of the mouth. Okay, next up is simple cuboidal. So now we're moving on to cuboidal. We'll notice that the shape of the cells themselves have changed into these little boxes, and they have those large round nuclei that are pretty much in the middle of the cells, if you're looking at the picture on the screen. So that's a good thing to remember, is to look at the nuclei, especially when determining between cuboidal and columnar, but we will get there. And so they're going to offer limited protection, and their big purposes are secretion and absorption, yet again, because it is a simple epithelium, it makes sense that it's going to be good at secretion and absorption and not so good at protection. So these are going to be found in our kidney tubules and some other ducts and portions of small glands. Oh, sorry, there we go. Next up is our stratified cuboidal epithelium. So this is actually very rare, and it is generally only going to be 2 layers. But if you look at this picture, you'll notice that some areas, there aren't 2 nuclei on top of one another. They're just kind of like bunched. So make sure that you're looking closely. And if you see even 2 sitting on top of each other, that isn't good enough to classify as stratified cuboidal. And stratified cuboidal is, its main purpose is protection. And it's going to be found in the largest ducts of our sweat glands, as well as our mammary glands and our salivary glands. So those are some larger glands in our body, whereas simple cuboidal is found in the smaller ones. Okay, next up is transitional epithelium, and this is probably our most specialized epithelium because it can tolerate large amounts of mechanical stress. And that is because it is found only in our urinary tract and mostly around the urinary bladder, although it can be found in the ureters and part of the urethra. And so the transitional epithelium needs to exist where it does because it allows the bladder to stretch and to fill with urine when it needs to. And so if you're looking at this image, you'll notice this steep drop off in the apical surface of the membrane. And so something to understand about that is this is probably an image of transitional epithelium when the bladder is empty. And so it's kind of raisined, like crunched in on itself. It's taking up, it isn't full to its maximum capacity. So this I would expect would be the image that you would see on an exam. So because it kind of tips you off that it's transitional. So make sure to study that. Okay, next up is simple columnar. So columnar is like a column. It's taller than cuboidal, and that will help you differentiate between the two. And the other thing that will help you differentiate, like I said before, is a nuclei. If you notice in this image, the nuclei aren't as central as they were in cuboidal, and it's more of an oval than a circle. So that's a little tip there. And simple columnar, it may or may not have cilia. The version that doesn't have cilia is going to be found in the digestive tract, and it's probably going to be responsible for absorption there. And if it does have cilia, it's going to be found in the bronchi, and it's going to be responsible for secretion of mucus from our goblet cells. And that cilia is going to create the mucociliary elevator effect that you'll learn more about when you talk about the respiratory system. Okay, next up is stratified columnar. Once again, this one is more relatively rare, but the interesting here is that one row, see if you see we kind of have 3 rows of cells in this image. One row looks what's pretty classically columnar, but the 2 below it look cuboidal. So don't let that throw you off. This is stratified columnar. And it's going to be responsible for protection and secretion, and it can be found in the male urethra and salivary gland ducts. Okay, last but not least, here we come to pseudostratified columnar epithelium, and this is the epithelium that exists to trick students and to give us trouble. So if you look at this at first glance, it kind of gives a stratified appearance because it looks like, because all those nuclei are all over the place, it looks like they're stacked on top of each other. But if you look really closely, you'll notice that all the cells are attached to the basement membrane at some point. And so actually, this is pseudostratified, not actually stratified. And so a good way to differentiate between pseudostratified and our other types of epithelium is that they're always going to have cilia, and they're going to be important for protection and secretion. And it's also found in the trachea and upper respiratory tract because those cilia are also helping with our mucociliary elevator. Those cilia, their job is to sweep our mucus up and out of our lungs and keep it from getting down to our lungs and keep it in our throat and nose. So it has a really important job, and you'll learn more about that as you go. But anyway, I wish you luck, and I hope this was helpful. But of course, if you have any questions, please stop by the Math Science Center or speak with your professors. Have a good one.